Hey everyone, my name is Rahul and today we are going to learn about the vectors. So as you can see in the title, vectors, the DNA of machine learning. So you might be thinking that why I have written this title, the DNA of machine learning. So means in the machine learning and the deep learning, vectors are the most important thing, okay? Or even in the Gen AI domain, when you are implementing the RAG or using the vector database, okay? So in that case, you must have a knowledge of vector. So you must have a fundamental knowledge of vector and the matrices if you want to begin with machine learning and the deep learning. So as you know that vector carries the fundamental information needed to build and operate machine learning model, same as the DNA carries the fundamental information needed to build and operate living organism. Yeah, so the goal of this topic today is to understand, visualize and apply the vectors in the context of data science and machine learning. So I have written here the four definition. Okay, so we will explore all these four definition one by one by like drawing the vectors in the graph. So you can see here a vector is a quantity that has both magnitude, that is length, and the direction. The second definition tells a vector is like an arrow. It tells you where to go and how far to go. The third definition tells a vector doesn't have a fixed position. It's all about the direction and the magnitude, but we can place it at any point. And the last definition that tells it also called the measure of displacement, that is delta x and delta y. We will be exploring all this definition one by one. So coming to this image, if you can see here in this image, there is a line having the arrow, okay, on the end. So this line with the arrow is called the vector. And what this arrow represent? This arrow represents the direction. Okay, so the starting point here is called the tail, and the ending point, the this arrow, okay, is called the head. So this tail is also called the initial point, and the ending point is also called the terminal point. And here, if you can see here, this length of the vector, okay, the whole length of the vector is called the magnitude. Now coming to the 2D coordinate space, I have already drawn one vector. Okay, so you can see here this vector start from the origin, that is x component is 0 and y component is 0, that is 0 0, and it ends at the coordinate 3 comma 2. Okay, so this vector is called the position vector, which always start from the origin. The position vector always start from the origin. Also, we have read in the above definition that we can place the vector at any point. Okay, so let me place one vector here. Okay, so in this case, this vector start from minus 1 1 and ends at the coordinate minus 3 3. Okay, so I can place the vector at any place. Okay, the vector will be drawn like this. It can also be drawn in this direction. It can be drawn in any direction. I can place the vector in any direction, depends on the data point. Okay, so now coming to this position vector, if you can see here, so how can I define this position vector? Okay, so I will travel 3 units in the left direction. Okay, 1 2 3, and I will travel 2 units in the upward direction, 1 2. Okay, so I have traveled here 3 units and in the left and 2 units in the upward direction. So the vector is always represented by v, and there is a arrow symbol above that, and we always write a vector in this square box. Okay, 3 2. So this vector represent the x component, the y component, and here 3 is the x component and 2 is the y component, and this vector is called the 2D vector. Okay, why it is called the 2D vector? Because it is in the 2D coordinate space. Now coming to the second example, so we have read about this position vector. Okay, now there is also another type of vector called displacement vector. Let me throw out that first. Okay, so this is the displacement vector. So this displacement vector start from 1 1 and ends at 6 4. Okay, so let me denote the starting point as point A and the ending point as B. Okay, so what the displacement vector tells, it tells that how can I start and reach at the ending point. Okay, so this what the displacement vector tells. And here this coordinate A coordinate, this A coordinate is defined as x1 y1, and this is defined as x2 and y2. Okay, so now I have to find the displacement vector. So displacement vector is denoted by A B, that is the starting point and the ending point, and the formula for that is x2 minus x1 y2 minus y1. Here it is 6 minus 1 and 4 minus 1. Okay, so the x and y component are of the vector are 5 and 3. Okay, so what this x and y component tell, that I am traveling 5 units in the left direction, 1 2 3 4 5, and I am traveling 3 units in the upward direction, 1 2 3. Okay, so I have traveled the 5 units here and 3 units here. So this is my delta y and this is my delta x. Okay, so yeah, this is the definition of the displacement vector. Now if you can see here, this is the vector represented in the 2D coordinate space. So there can be a vector in n-dimensional space. Okay, so what is n-dimensional space? The human mind or humans can visualize up to 3-dimensional space, but if we want to visualize above in above 3-dimensional space, then we have to do it mathematically. We cannot visualize that. Okay, so we can also write this vector, this. Okay, we can also write the vector like this also, x1 x2 up to xn. So this is called a vector in n-dimensional space. So here you can see that there is a difference. This is the column vector and this is the row vector. Okay, similarly I can also write the vector in 3-dimensional space, x1 x2 x3. So this is the vector in the 3-dimensional space. Okay, now I want to find the what is the magnitude of vector. So let me draw one vector here. Just a moment. Let me again draw the vector. Yeah. So if you can see here, this vector starting from the origin and it ends at 3, 2. So I need to find the length of the vector. So how can I find that? Okay. So you must be aware of the Pythagoras theorem. You might have studied in the high school. Okay. So what the Pythagoras theorem tells, if I define this point as A, this point as B, and this point as C. Okay. So let me draw one line here, small line. Okay, so the formula of a Pythagoras theorem is AB square plus BC square equal to AC square. Okay, now here I want to define the length of this vector. Okay, that is AC square. So here AC is root of AB square plus BC square. Okay, So here the root of 3 square plus 2 square. Okay, so it is denoted by 9 plus 4. So this is root of 13. Okay, so the length of this vector is root of 13. Now coming to another vector. Okay, so this vector is called the unit vector. So why we call it as a unit vector? So suppose you have the original vector. Okay, so you have this original vector, this one. Okay, so this vector ending point is 3 4. Okay, so now you want to scale down this vector. Okay, you want to scale down this vector. So how you can scale down? Okay, so scale down to the vector so that it length become 1. Okay, so let me calculate first length of this vector. Also I forgot to tell you here the magnitude of vector is denoted by two bars on left and right. Okay, and it is denoted by root of 13. Okay, so now I want to find here the magnitude of this vector. Start the vector start from origin and it adds at the coordinate 3 4. So I will try to first find the length of that. So here suppose I will draw one line here, 1. Okay, it ends at 3, and another line here. So I'm drawing this line to understand, we can understand visually how we are applying the Pythagoras theorem. Okay, so A, B and C. So I want to find the length of this vector. So here I will write V, and so this is the length of my vector. Okay, uh, this is I am traveling 3 units in the left direction, so it is 3 square. Okay, then 2 units in upward direction, so this is a 4 square. So this is 9 plus 16, it is root of 25. Okay, so the actual value length of this vector is 5. So the length of this line is 5. Now I want to find the unit vector. So how what is a unit vector? Unit vector is a scaled down version of this vector. So its lengths become 1. Okay, so the unit vector always have a length of 1. The length of unit vector can never increase by 1. It is a constant 1. Okay, so how can we find it? So the length of the unit vector is defined by vector v upon magnitude of vector v. Okay, so here what is vector v? In this case, if we find the vector v, okay, sorry, I have drawn the arrow not proper. So this is vector v. Okay, so I want to define the length. Okay, so how can I want to define the component of the vector v. Okay, so the component is x2 minus x1 and y2 minus y1. So it is 3 minus 0 and 4 minus 0. So it is 3 and 4. Okay, so based on this definition, I can write 1 by 5, that is 5 is the magnitude of vector. Okay, so 1 by 5, and here it is 3 and 4. Okay, so when I divide this 5 with the x component and y component, okay, I will get 0.6 and 0.8. So this is my unit vector having the length 1 but the direction of this vector. Okay, so the component of this vector you can say 0.6 and 0.8. So in unit vector we can say the length always remains 1, but its direction can change, and it is a scaled down version of the original vector. That is, here the original vector was 3 4, and its scaled down version is 0.6 0.8. So suppose I have a unit, this is my unit vector, and I want to confirm that it has length of 1. Okay, so how I will confirm is I will write here. Okay, I will try to find here the magnitude of this unit vector, that is 0.6 square, 0.8 square. Okay, so it is 0.36 plus 0.64, which is nothing but 1 here. So this is the unit vector. So in this lecture we have just revisiting what we have studied so far. So in this vector we have studied about the definition of the vector, how vector works, how vector is represented, uh, what are the different type of vectors. The one is the position vector, the second one is the displacement vector, and we also figure out how we represent the vector in the n-dimensional space, even in the 3D space. Then we are able to find out how we can find the magnitude of the vector. Okay, that is the length of the vector. And the last we have studied is the unit vector. So yeah, I forgot to tell you one more thing. The unit vector is represented by, uh, let me write here. The unit vector is represented by v hat. Okay, so the caret symbol is called, is above the v. Okay, so it is called the v hat. So it is represented by vector v upon the magnitude of vector v. So rest of the calculation we have done, and there is second point I have missed earlier. So here, so this is the magnitude of the vector. Okay, so the magnitude of the vector, suppose I am defining it as a distance d. Okay, which is the length or the magnitude of the vector. It is defined by x1 square plus x2 square. Okay, but this is the formula for the magnitude of vector in two-dimensional space. For example, we need to find the magnitude of the vector in n-dimensional space. Then we will write it as here d x1 square plus x2 square plus x3 square up to xn square. Okay, so these are the n-dimensional vector. Yeah, that's it. And thanks for watching my video.